Hey guys, I hope everybody is having a good morning so far. So today I wanted to jump into 12.2, and here we're going to talk about angles and angle measure. So first of all, let's recall how we form an angle in the first place, right? So to create an angle, first you start with a ray, just like the ones you saw in geometry. Then what we're going to do is we're going to rotate away from the ray, right? And when we stop at a point and there we draw another ray, voila, we've created an angle. All right, now that initial ray that we started with in our new angle will be called the initial side. And then after we rotate, that second ray that we draw is called the terminal side. And if you can remember from geometry, the point where those two rays intersect is called the vertex. So that's just a generic angle. And of course, I can have my angle oriented in any direction. However, it is a lot more meaningful in this context, starting now and moving on to upper level math, if we were able to lock that down in a particular orientation. So let's move on to what it means for an angle to be in standard position. We say an angle is in standard position if the vertex that we saw here is at the origin, and the initial side lies along the x-axis. So if we go to this diagram down here, look at that angle. The vertex is at the origin and the initial side is lying along the x-axis. Those two must happen in order for this to be called in standard position. Once we do that, like we said before, we still rotate away from that initial side, and we can rotate to, any degree that we want. And then same way, the end point, we draw another ray, and that's called the terminal side. Okay? So that's what it means to have an angle in standard form. Now, you notice I've been saying we rotate away from the initial side. I haven't really specified a direction like up or down and so on and so forth. So the reason for that is if I have an angle in standard position like this, all right, so here's my initial side. Now I can either rotate up or down. Now in math, we don't really say up or down. Instead, we use the words clockwise or counterclockwise. So let's think about a clock for a minute. And if these are the hands of the clock, in what direction do the hands of the clock rotate? Well, they go towards the right like this, right? We call that direction clockwise. The opposite direction, so sort of, moving to the left like this, is called counterclockwise. Okay? Now, because we always like to spice things up in math or physics, the positive direction is actually the counterclockwise direction, and so the clockwise direction is actually the negative direction. So if we come over to the left side of the screen here, where I was beginning to draw my angle in the initial position, in the standard position, here is my initial side. Now, if I were to rotate away from this in the counterclockwise direction, then what I create with my terminal side is a positive angle. And if I have an angle in standard position like this, and from here if I rotate in the clockwise direction like this, like the way the hands of the clock would move, that would create a negative angle. Okay? All right, so just to repeat, positive angles result from a counterclockwise rotation, negative angles from the clockwise rotation. And you can see another visual here. You have an angle that way. That's a positive angle this way, and then this angle to the right is a negative angle. All right. One thing I sort of skipped over is angle measures, right? And this is something that we've already encountered and seen before. When I have my initial side drawn here, and I haven't rotated yet at all, I have no angle. So essentially, I have a 0 degree. As soon as I start to rotate, I increase the number of degrees. So I go from 1 to 2 to 3 to 30 to 45 and so on. And then when I get to this point, I have an angle of 90 degrees. If I rotate further here, I have an angle of 180 degrees. Further would give me an angle of 270 degrees. Further back to my initial, and I have progressed 360 degrees. So keeping that in mind, what we're going to do here is we're going to draw some angles in the standard position. All right, the first one we're going to draw is an angle of 210 degrees. Okay, so we start, because it's in standard position, with the vertex at the origin and the initial side aligned with the x-axis. Now I've got an angle of 0 degrees. Okay, I need 210 degrees. So I start rotating upwards or counterclockwise, and now I have 90, 180, and now I need 210, so I need to go about 30 more. Now, we're going to eyeball here, right? So 210 will fall right about there. Okay, so what is it that you need to show here? All right, so if you show me, if you draw this, let me erase this for a minute. That is not good enough, because those are just two lines, random lines. One of them happens to coincide with the x-axis. That's not good enough. What I need to see is A, that line with an arrow. B, I need to see this rotation arrow indicating the direction of rotation. And yes, it does need an arrow, because without the arrow, I don't know which way you rotate it. And then I need to see that third line with the arrow at the end. Okay, these are a must. And, you know, these are ones where I would expect that you are gaining a lot of free points. So please, 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 let's be careful with all of this. All right, so it's important for us to be able to draw this and then to very quickly identify the quadrant in which our terminal side lies. All right, and if you recall quadrants, this is quadrant 1, and look, even here we always went counterclockwise. This is quadrant 2, this is quadrant 3, and this is quadrant 4. So this angle 210, because the terminal side is in quadrant 3, we say the angle 210 lies in quadrant 3. Okay, let's do another one. Now I need to draw negative 40 degrees. Okay, so positive or negative, my initial side is always this. Now I need to draw an angle of negative 40 degrees, which means I need to go in the clockwise direction. So in essence, downward from here, 40 degrees. Now remember, if I go halfway in that square, that's 45. So 40 is roughly there. All right, now I have no way of knowing whether you drew a 40-degree angle or a 43-degree angle. So we're going to eyeball. Okay, just be consistent. Again, I put that rotation arrow there. That's a 40-degree angle. Okay, and this one lies in quadrant 4. Okay, here I need to draw an angle of 470 degrees. So here we go. I have my angle in my terminal side, and now I'm going to go positive 470. So when I rotate 270, 360, I need to go a little bit more, right? So I made a full circle, I went 360, but I still have more to go. How much more do I need to go, I wonder? 110 degrees. So from here, I'm going to, I'm going to continue one long spiral past the 90, and 110 is somewhere there. And again, you need the arrow because I need to know the direction in which you rotated. So that is an angle of 470 degrees. You can see that it lies in quadrant 2. Okay? All right, so now that we've done that, we're going to do a little bit of an experiment here, an illustration. We're going to draw the following angles in standard position on the same axes, right? You might already, be able to guess what's going to happen, but we're going to do it anyway. Don't ruin it for anybody. All right, so first I'm going to draw this 40-degree angle. Boom. Boom. Okay. Good enough. Okay. Next, I'm going to draw in red the 400-degree angle. Here we go. All right. And 360. Okay. How much more do I need to go? 40 more. And right there. Oh my. What do you notice? The 40-degree angle and the 400-degree angle. If I take away those spirals, they're essentially identical angles. They're the same exact angles, right? So what does that mean? How did that happen? How did that happen? Well, because I had gone 40 degrees, and then from the 40, how much more did I need to go in order to make it 360? I'm sorry, in order to make it 400. I gave that away. Well, I went 360, right? I drew the 40, and then on top of the 40, I went another 360 to make it 400. Well, look, if this is my 40-degree angle, and if I go 360 on top of that, I made a circle, so I've come back to the same place. All right? So now, I have two very different measures here, a 40 degrees and a 400 degrees. But you can see that both the 40 and the 400, they have the same initial side. Well, they all have the same initial side. That's the x-axis. But they have the same terminal side. Right? And guess what we call two angles or two or more angles with the same terminal side? You guessed it, coterminal angles. All right? So coterminal angles are two or more angles in standard position that share the same terminal side. Okay? So how do I find, if I have an angle, how do I find a coterminal angle? Well, how do I get to the same place? By adding or subtracting a multiple of 360 or 2 pi. We'll talk later about what that 2 pi means. Okay? So, let's go over that again. Here is an angle of 60 degrees. Okay? Now from here, if I add 360, I come back to the same angle. If I add another 360, I come back to the same angle. If I add another 360, I come back to the same angle. So I can add 360 or 2 times 360 or 3 times 360, right? I could keep adding 360s as much as I want. Or what I could also do is from that angle, I could go in the opposite direction and subtract 360 and come back to the same point. All right? So what we're going to do here is we're going to find one positive and one negative angle that is coterminal with the given angle. All right, so what I do is, for the positive one, I start with 210, And to that, I'm going to add 360. And when I add 360, what do I get here? I get 570 degrees. Okay, is that a positive number? Yes. So that qualifies as my positive coterminal angle. Now I need a negative coterminal angle. This time, I take my 210, and what I'm going to do is I'm going to subtract 360, right? And when I do that, I get negative 150 degrees. Is that a negative value? Yes, it is. So now I have found a positive and a negative coterminal angle. And those are your answers, and you're done. Okay? All right, now I have a negative 120. Okay, so how do I get a positive? Well, from the negative 120, if I subtract, that'll give me a negative number, so that won't do. So what I do is I take 120, I add 360, and that gives me 240 degrees. So ask yourself, is that a positive number? Yes, it is. Was I looking for a positive coterminal angle? Yes, I was. So that's one. For the negative, I'm going to take the 120 and subtract 360, and that's going to give me negative 480 degrees. Is that a negative value? Yes, it is. So I'm good to go. Okay? All right, let's do this one. Positive. Now I have 580. Okay? So I take the 580 and I'm thinking to myself, oh, positive coterminal angle? That's easy. I just add 360. Okay, let's do that. And I get 940 degrees. Now, is that a positive value? Yes, it is. It qualifies as a positive coterminal angle. Now, we're going to do the negative coterminal angle. Okay, you know what? Let's subtract 360. What does that give me? It gives me 220. But wait, is that a negative value? No, it's not. So that can't qualify as a negative coterminal angle. It's got to be a negative value. Oh my God, so what am I going to do now? I know what I'm going to do. I'm going to take the 220 and guess what? Subtract another 360 from that, and I get negative 140 degrees. Now, is that a negative value? Yes, it is. So that qualifies as the negative coterminal angle. Okay, what about this 220? Okay, and the 940? Which one of them is actually a coterminal angle? Well, guess what? They both are. There can be multiple, infinite numbers of answers for these. As long as you get a positive value, and you got that positive value by adding or subtracting series of 360s, then you're good to go. Okay, so for your answer, you can either put this or this for the positive coterminal angle. All right, and it's completely up to you. So if you realize, okay, 580, you know what? I'm just going to subtract from the beginning, and on the way, I'll hit a positive and a negative coterminal angle. You know what? All the more power to you. Okay? All right, so let's do another one. Negative 800. Okay, so look at what's going to happen here. I'm not going to label negative or positive right now. I'm going to take negative 800, and you know what? I'm not even going to subtract. I'm just going to add 360. And what's that going to give me? Negative 440. Okay, I need a positive value and a negative value. Okay, I could use that as my negative coterminal angle. Let's keep going. So add another 360, and I got negative 80. Now take negative 80 and add another 360 until I hit a positive value, and finally I get 280. So now this definitely is going to qualify as my positive one. And for the negative one, I can choose either of these. Okay, so that's a much more efficient way of doing it. You just do one operation, we only added 360, and on the way, we were able to come across both a positive and a negative. Isn't that cool? It really is. Okay, now for my favorite thing in the world, guys. I'm so sorry I can't be there live with you to do this. Okay, let's go at it. Degrees are one way we measure angles, but there is another. Just like when you measure height, you can either measure in feet or inches or in meters, right? So you can either do feet or meters, different standards of units. It's the same with angles. We can measure in degrees or we can measure in radian. Okay, so what exactly is a radian, right? Okay, let's suppose, right, our school gets some funding for a, like a track, like for track and field, right? But the person who donates it happens to be a mathematician, and he says, I'll give you the money, but the one thing is, you have to build a perfectly circular track. None of that oval stuff, right? So we build this circular track like this circle that you see on this page. And because we all love math, the first thing we do is, oh my gosh, this is a circle. Let's go out and measure the radius of this track, right? So you measure the radius of this track, and it happens to be, this radius happens to be 10 meters, okay? So your coach, who is also a mathematician, puts you right here where the angle is 0, right? And he slaps a pedometer on you that would measure your steps. And he says, okay, you have to walk the exact length as this radius. So basically you have to walk 10 meters across this field, okay? So you're like, okay, I can do that. So you start walking along this and here, right? You get to that point and you stop. Your pedometer beeps. You have walked 10 meters. So that curved distance, right, when we measured in steps, you have walked 10 meters. So how much have you walked? You have walked the exact same distance as this radius, right? So now, what have you done? You have no idea what you've done. If you actually draw another radius here, look, you made an angle, okay? Now, how much of an angle is that? Well, how much did you walk? Let's take a ratio here. The amount that you walked, we call that arc length. Oh, what happened here? Oh no, it went away. That, guys. So the amount that you walked, we call that arc length. That's another one that you learned in geometry last year, isn't it? So now, if I did arc length over radius, right? Just the ratio of the arc length to the radius, because, trig, it's all about ratios, Arc length over radius, what would that give me? 10 over 10, that's a 1. So what does that mean? When you walked the same distance as the radius, that angle you made is equivalent to 1 radian. Okay? All right, and you're like, you know what? This is kind of fun. I'm going to tell my friend to walk twice the distance as I did. So now here's your friend, and he walks not 10 meters, but 20 meters. 20 meters is not that big. Right there, right? So now that's the angle that your friend makes. So what's his ratio? It's 20 to the same radius of 10. How much is that? That's a 2. So guess what? The angle that he made is 2 radian. And so the other guy, guess how much he walks? He walks 30 meters. And now he's got an angle right there, right? Well, how much is his angle? Well, it's 30, the length he walked over that radius, 3. So the amount that he walked, that's 3 radian. And now this other guy here, he's walking. He gets to this point and he's all of a sudden he's tired. So he stops. He just stops. He's like, oh my God, it's too hot. I can't do this anymore. I'm not used to all this walking. He just stops. Okay, so let's see his angle. Oh, look. That made a diameter. What did this whole thing make? Oh my God, that's a semicircle. Okay, so he measures, okay, he looks at his pedometer. How much has he walked? Because he just stopped short. 31.14 meters. I'm sorry, 31.4 meters, right? So what is his angle then? This, he stopped short, this guy, he can't even walk. 31.4 over 10, how much is that, guys? 3.14. That's how many radian that is. 31.4 radian. Wait a minute. That strikes a bell. How much is what's 3.14? Wait. Is that pi? That's pi. Oh my God, that's what pi is? That's what pi is? Holy moly. Okay, how much is this angle? How much? It's a half a circle. How do we make half a circle? How much is that angle in degrees, guys? Oh my God, it's 180 degrees. Oh my God, hang on, mind blown. Where is that emoji when you need it? Wait, are you telling me that 180 degrees and pi are the same thing? Actually, that's exactly what I'm saying. 180 degrees and pi are exactly the same degrees. So, in radian, an angle that has 180 degrees has a measure of pi, right? So, this you need to take with you basically for the rest of your life, that 180 and pi are equivalent. And keep that visual in mind, that diagram of you walked half the circle, you covered 180 degrees, but pi radian, okay? So, and like this, you know what? Okay, now that our minds have been blown with this, let's think about this for a minute. Suppose I walked the entire circle, okay? What's the word, the mathematical word for the distance around the entire circle? I know you know, it starts with a C. It's circumference. Okay? Okay. And how much is circumference? Yes, it's 2 pi r. So, let's go back to our arc length and radius. Suppose I walked the entire circle. That's 2 pi r, right? Okay, divided by the radius, if I take the ratio with that to the radius, what is that? How much of an angle is that? 2 pi, right? So what does that mean? The entire angle is equal to 2 pi. I'm sorry, the entire circle is equal to 2 pi. All right, again, mind blown. So much of your life in trig will become easier if you could just make this a part of your life. Just like when I ask you what your name is, you don't even have to think twice, and you will tell me Ethan or Max or Sydney or Alexi. It's the same exact thing. When I ask you what's 180, you've got to say it's pi. Okay? Now, we're going to just know that. That's it. We know that. And once you know that, you know what you could do? You could now freely convert back and forth between radian and degrees. So here I have a couple of angles that are in degrees. Can I write them in radian? Well, of course I can. All right, so here we go. What you're going to do is you're going to use the fact that 180 degrees is equal to pi. And what we do is, this is what we have to convert, the 30 degrees. I always do times a fraction bar. Now, what is it that I want to get rid of? I want to get rid of degrees. Here in the 30, the degrees is on top, because technically this is 30 over 1. Degrees is on top. It must go on the bottom here. So I put 180 here. That means pi goes on top. And now all I have to do is simplify. So I get the 3 will give me a 1. This will give me a 6. So I get pi over 6. Okay, let's do it again here. In B, times and a fraction bar. I need to get rid of the degrees, which is on top. So degrees goes on the bottom here. Pi goes on top. All right, so now what are we going to do? We're going to basically simplify the 135 with the 180. And if you do that, you should be able to do these by hand, by the way, if this shows up in non-calculator part. So we're going to get a 3 here and a 4 here. So this is 3 times pi over 4. Usually that's how we write it. I know somebody's going to ask me, well, can you say 3 over 4 times pi? You can. It's just convention to write it this way. So times fraction bar, degrees on top, it goes on the bottom, pi goes on top. So now I need to simplify 240 over 180. And you can cancel an equal number of zeros. So here I get 4 pi over 3. Okay, so this one here, again, times pi over 180. Now, cancel this and cancel that. You're going to divide by the 9s. Notice there is a negative here. It just stays out here. It doesn't bother anybody. And that's going to be, negative 3 pi over 2. All right, here we have to go the opposite direction. We have to write the radian measure as degrees. So same exact thing, times and a fraction bar. This time, pi is on top. It goes on the bottom. So 180 goes in the top. Pi's go away. And now, if you cancel with the 3's, I get a 60 here. So now I have negative 2 times 60, negative 120. All right. Similarly here, 180 over pi, I get 30, pi's go away, 210 degrees. This one, 180 over pi, pi's go away. And now what I want to do is, if I reduce the 4 with the 180, I get a 45 times 11, 495 degrees. These are all degrees. Here, okay, now this one, there is a negative, so I need to put a negative here. Okay, now you can obviously do that process here. You can also think to yourself, okay, this is pi over 2. Half a pi. I just learned that pi is 180. Half of 180 is 90 degrees. And, and I'm totally fine with that. Okay, this will be in a non-calculator section anyway. So that's what I want. I want you guys to be able to just reason that out. Okay? Okay, now we did coterminal angles, but with degrees. Now let's do coterminal angles in radian. So to do coterminal angles, what we had to do is either add 360 or subtract 360, right? Well, in radian, I'm going to add 2 pi or subtract 2 pi. So let's do that. Here, For the positive one, I'm going to do 2 pi over 3 plus 2 pi. And here, you need to be as quick with these as you possibly can, right? So here's my quick trick. The denominator of 3 will be consistent, 3. Now we're going to do this loop. 3 times 2 pi is 6 pi, plus 2 pi is 8 pi over 3. All right? Negative coterminal angle, 2 pi over 3 minus 2 pi, same denominator, multiply. 3 times negative 2 pi is negative 6 pi, plus 2 pi, negative 4 pi over 3. Okay? All right, what I want you guys to do now is go along with me for a minute. What I want you to do is I want you to pause. Okay, just hit pause on this, and I want you to go ahead and do B and C. I'm just going to continue, but I want you to pause and do B and C. Okay? All right, so hopefully you paused and you did all that on your own. I did want to, keep the work in the recording. So these were straightforward, but here, this is the negative, all right? However, any one of these could be a positive coterminal angle, all right? So now, again, go ahead and pause and do D. This time, I'm not going to show you the work. I'm just going to write the answer. Okay, and that's what we have for those, all right? So actually, guys, I'm going to stop here for today. So if you've watched up to this point, you can go ahead and pick up a handout, which is going to be your homework. The handout just includes the stuff until here. So I'm going to stop here because I'm going to change things around a little bit. Next class, we will go over the rest of this, right? And we can just, put everything together. Now, I want to remind you before you close this that there is bonus tomorrow, Friday. So if you want to come, please feel free. I will be in room 259. All right. Thank you very much, everybody. If I don't see you, have a great weekend. And if I see you, that will be lovely as well. Bye, guys.